Our next speaker is a well-known kernel developer, our dear guest, Harald Welte. He will talk about open source mobile communication.
Okay, thank you for attending this presentation. Thank you to the organizers for inviting me again. This marks my 10th anniversary at DORS at CLUC. I've been here 10 years ago. Is there anyone else in the audience who has been here 10 years ago? Ah, okay, so a few of you. Okay, good. Today I'm going to talk about Osmocom, which is an umbrella project about the various different sub-projects in mobile communications, so open source for mobile communications. Now, when people think of mobile communications, they think of Android and smartphones and all kinds of things, but that's like 10, 12 layers up the stack from what I'm talking about. I'm talking about the infrastructure of mobile communications, not the applications or the users or something like that. It's the infrastructure, the technologies, the protocols. So when you look a little bit at the internet and TCP/IP and Ethernet and the protocols that most people are more familiar with, and you look at mobile communication protocols, you will find a large discrepancy. So my background is mostly communications security, and I was looking a lot at TCP/IP securities in the 1990s, participated in packet filter development and so on. And then from 2005 onwards, I was looking at GSM mobile phones and mobile protocols, mobile technology. And basically, you can see that if you want to do some research or some experimentation or some hacking on TCP/IP or Ethernet or Wi-Fi, all you need is, you need your random x86 or whatever architecture computer. You have an Ethernet card that's built in today in all the machines. You take your Linux or BSD protocol stack that implements all the different protocol layers, and you can start to experiment with it. You can build your own network with routers, with packet filters, with network address translation. You can modify TCP congestion control algorithms if you want to do that, and you can basically innovate and create and be creative with technology. So in terms, if you're a scientific guy, then you can do your modifications, you write a paper about it, you can publish the results, and you can publish your code. Now, if you look at mobile communications, that's very, very different. Because, before 2009, when we started the Osmocom project, there were no open source implementations of any of the protocols that are involved in mobile communications. You had almost no university that was able to afford and operate a test lab with the required equipment. In Germany, I'm only aware of 2 universities that had an own GSM network where they could basically test something new. But even there, all the components are black boxes, proprietary software, so they couldn't really modify the code or modify the systems. They can just switch it on and explain to students how it works, and then they can switch it off again. So it's not really something where you get hands-on experience. At that point, you can say, this is too hard. I'm going to go back to doing research on TCP/IP or Ethernet like everyone else does. Or, maybe if you are a university or some research organization, you can partner with a commercial company like Qualcomm or Nokia or anyone who has access to the technology. But then in return to access to the technology, you have to sign an NDA that restricts you. You cannot publish your results as freely as you want, and so on. So it's not very attractive for researchers who want to share their results publicly. Now, if you compare the internet world with mobile communications, you have to start with the observation that both of the specifications of those technologies are equally available. So if you want to learn about TCP/IP, you can go and read the RFCs, the actual specification documents. They are all made available by the Internet Engineering Task Force. You can also, there's tons of textbooks, of course, about TCP/IP, from the classic TCP/IP Illustrated, from W. Richard Stevens, to many, many other textbooks. You have the entire protocol stack implemented in many different open source and proprietary implementations, from small embedded systems to large systems like Linux. And also you see lots of scrutiny in terms of security research on those protocols. The 3G specifications or the GSM specifications are equally available. You can go to the website of the 3GPP, which is the standardization body, and you can download each and every of those specifications, explaining the system in very detail, from the radio layer through the physical layer, the modulation, down to the entire protocol stack, all the different protocol layers, the network elements in the network, and so on. So the information was as public as it is for the internet, but in terms of implementations, it's completely a different different situation. And I think the reasons for that was that, well, the industry involved with mobile communication is a very closed industry, and closed-minded, I have to say, in a lot of cases as well. It's an electronics manufacturing industry. You know, the kind of exposure to open source software or to this kind of philosophy has not been there in electronics companies as it has been in the software companies or software community in the internet. We only had very, very few closed source implementations of those protocol stacks, and the chipset makers, the companies that build actually the chipset to access the radio, they never release any hardware documentation, most often not even to their customers, to their paying customers under NDA. So let's say you're building a phone, and I was part of a company that was developing mobile phones. Then even you as the mobile phone manufacturer, you, let's say, as somebody like HTC, you do not get the full documentation on the chipsets that you use in your product, because Qualcomm keeps them secret or Infineon keeps them secret. So you just you get a chip and you get some binary libraries and you run it, and you don't really know what's happening inside. So the information is extremely restricted. And well, now why would anyone be interested in that? And particularly in case of my background, why would anyone be interested in security aspects of that? Well, a lot of people think, oh, it's nice, you can listen to phone calls and do all kinds of strange things. I personally think listening to phone calls is boring. What's really interesting is machine-to-machine communication, if you think what's out there, right? BMW cars, for many years, you can have remotely unlock and lock the cars over GSM modems built inside the cars. You can call BMW and you can say, oh, I locked myself out of the car, and you authenticate yourself on the phone with some password, and they remotely open it. And I'm quite sure they're not the only manufacturer. You get burglar alarm systems that are controlled by GSM. You have smart metering for electricity and other utility companies. All over Europe, it's mandated that railways deploy railway GSM for controlling trains. If you have access to railway GSM, you can actually send speed limits to trains on tracks, and you can send emergency halt commands to trains and so on. It's quite crazy. You see vending machines, well, Coke vending machine maybe is a bad example, but anyway, vending machines of all kinds of goods. When their coin box is full, they send an SMS over GSM. If you can sniff that, you as a burglar, you know when the coin box is full and when you can steal the most efficient amount of money. Right? There are other things like the power plants, the wind-based power plants. In Germany, quite often they're controlled over GSM as well, and I'm not sure how that is in other countries, but at least in Germany it's the case. So the point is, they're not always feeding power into the grid, but they need to be explicitly instructed whether they are allowed to do so or not, because the demand needs to match the production, and if there's not enough demand, you cannot feed more electricity into the grid. How do you remotely switch on and off that? By using GSM in the end, by using mobile communication networks. And so there are many other things, including transaction numbers for popular mobile banking systems that get transported over mobile communication systems, which I think personally are much more interesting to look at rather than tapping into phone calls. So turning more towards the Osmocom project. Well, Osmocom means open source mobile communications. It's a project that we founded basically to have an umbrella about various different free software projects that relate to one type of mobile communications technology. So it's a classic collaborative, community-driven, free and open source software project. We have lots of people involved with various backgrounds. Almost nobody has worked in mobile communications before, so they are all just people who are looking for an interesting new hobby, a new challenge. We communicate like most free software projects over mailing lists, IRC, All our source code is available in Git repositories. We have track and wikis for the information sharing. We use mailing lists, and you can find all that under the osmocom.org umbrella. So what kind of projects are there? Well, there's one project called OpenBSC, which was the first project under the Osmocom umbrella. And it implements a certain part of the GSM network. I'm going to speak more about that tomorrow. That's a separate talk, so I'm going to quickly skip that. The point basically is, by using some hardware such as this and some antennas glued to a tree, like a very poor amateur, you can start your own GSM network. We actually used this installation in 2009 at a hacker camp called Hacking at Random to run a local mobile operator inside the camp, a completely autonomous GSM network. Now, as I said, I'm going to talk more about that tomorrow. I rather want to focus on the other mobile communications projects that are inside the Osmocom umbrella. One project is called Osmocom BB, where Osmocom, well, I already explained that. BB is for baseband, and it refers to the baseband chipset, which is the chipset in a mobile phone that actually talks to the radio, that actually transmits and modulates data and receives data and controls all the analog circuitry around it. So we reused existing telephone hardware, certain phone models which were sold under the Motorola brand. Motorola is not the actual manufacturer, but it was sold under their brand. And we reused that hardware, but we rewrote the protocol stack for the mobile phone side on this mobile phone. So that includes layer 1, layer 2, layer 3, and all the protocols that are involved. We reused some of the code that we had written for the network side of GSM before. And that's used in quite a number of universities and other research contexts ever since. This project was released in 2010. So there's a small picture of such a phone circuit board on the bottom. You can find lots of more information on the project homepage, right? So using this hardware, which is very cheaply available for about 20 euros, you can buy a used phone that supports this chipset, and the Osmocom BB software you can, and a laptop that you attach it to, you can run a complete phone out of open source software, out of free software, without using any proprietary protocol stack or any element in that context. So what kind of use cases do we have? Well, it's used a lot for security research and has gathered lots of interesting results over the years. It's also a very good example how students of communications technologies can learn how the system actually works in detail. You can follow and trace every step, right? It's just the same things that you have in IP networks. Like you can just start Wireshark and you can look at the protocol trace and see what's happening in an IP network. The same thing you can do with Osmocom BB on GSM. So you can see each and every radio message that your phone receives or that it transmits. You can follow the processes. You can see what's happening. When does the phone register? What are all the signal strengths? What kind of requests are being made from the phone? Is anyone sending me silent SMS messages? I'm not sure whether that has had any discussion in Croatia. In Germany, that's in media discussion in the last few years, that police is using hundreds of thousands of so-called silent SMSs to track people and to, it's basically an SMS that's sent to you, which you as a user, you don't see that you're receiving it. But by creating traffic in the GSM network, they can know exactly where you are at that point. So they keep sending you those silent SMSs in order to track suspects or even not so suspects. Of course, using a phone that has free software, you can immediately see that somebody is sending something like that to you because it's no longer hidden from you. You see what's actually happening. Well, another project we have in the Osmocom project is called OsmoBTS, which is actually the software the lowest level software that runs on a base station hardware, which is what's in the cell towers, what builds a mobile communication networks. It can run together with OpenBSC and other software that we wrote to form an autonomous GSM network where not only the central elements but also the base transceiver stations, the BTSs, are running on free software. We also have projects in other communication technologies. I'm not sure how many of you have heard of TETRA before. It's called terrestrial trunked radio, which is a radio system that's used in Well, pretty much all over the world except North America for police and firefighters and emergency services. It's basically for official purpose. But also there are a lot of private Tetra networks. In Germany we can find, for example, the subway in Berlin, the communication of the subway system works on Tetra. A large electricity company called Vattenfall Europe has a Tetra network to coordinate their communication. You can find power plants, airports, and so on that all use this radio technology. We, in the Osmocom project, we implemented a software-defined radio receiver. So using a very cheap piece of hardware, again, something like 15, 20 euros, you plug it in the USB port of your PC, and then using the Osmocom Tetra software, you can again receive and decode the full protocol traces of this network. You can run it in Wireshark. We wrote the respective Wireshark dissectors, so you can actually see what's happening in the Tetra network. And one of the funny results in Osmocom Tetra was to discover that at that time, when we first wrote the code, the police in Belgium was using their system completely unencrypted. So by using this receiver, you could listen to the supposedly secure police radio system. And also in Germany, all the airports that I've been to, and also Vattenfall and many other companies, they use their Tetra networks without encryption or without authentication. And then you read news articles that Vattenfall, the electricity company, is using Tetra to control their some electricity grid features, and there's no authentication and no encryption. And then when the press actually, as a result of those revelations, the press contacted Vattenfall about this, they said, oh yes, we know that this is possible, but it's illegal if anyone does that, so that's fine. So security, why do we put locks on our doors? You know, entering the building without permission is illegal anyway, so why do we need locks? Sort of that kind of logic. It's quite strange. So anyway, you can explore Tetra networks using this Osmocom Tetra software. We have a similar software for a system which probably nobody has ever heard of. It's called GMR, Geo Mobile Radio. Some of you may have heard of a satellite telephony network called Thuraya. That's a well, almost global, excluding the Americas, so basically all over Europe, Asia, Africa, and Australia. You have coverage using satellite phones with this network, and we also implemented a receiver for the satellite network. So using a small antenna, and again your 20 euro cheap USB receiver, you can decode, demodulate, and get protocol traces of this satellite telephony. Now, the interesting thing is when you start to investigate that and you start to read the specifications of those systems, is they have interesting features, such as that every time somebody places a call in the satellite network worldwide, when you press the dial button, the telephone will send its unencrypted GPS position up to the satellite, and the satellite will send it down again on basically on the planet. So by putting up an antenna, you can see the exact GPS position of each and every person that's currently using this satellite telephony system. And I've been interviewed about 2 or 3 years ago about this, that we discovered this. I mean, it's written in the specification. People just have to read the specs and they could find out about it, but still nobody knows about it because apparently nobody thinks it's fun to read specs. So I actually called this the let's shoot Gaddafi feature because I cannot think of any other conceivable use case other than for intelligence services to exactly know where people are. And the funny thing is, you can actually not only receive the communication that's locally for you, because the satellite has many spot beams. Basically, normally a spot beam shouldn't cover more than, let's say, half of Germany or something like that. But even inside Germany, with a regular satellite dish, you can still receive signals that are intended for sub-Saharan Africa and for the Middle East. So still that all you can receive with a standard satellite dish in Germany. It's quite funny. And we are not the first ones who are doing this. You can find commercial signal intelligence companies that have been offering proprietary products for quite some years. And you can find marketing slides where they draw a map and they actually put dots on the planet where all of the phones are and which numbers they are dialing and so on. It's quite fascinating. But anyway, now since we started with that, people actually also in the Osmocom project and associated with that reverse engineered the crypto that is in there. There is an encryption system, but it's even weaker than the one that we have in GSM, so you can break it in near real time. The only thing that was slightly harder, the slide is actually outdated, is the speech codec, because the speech codec by which the speech is compressed is completely proprietary and not documented anywhere. And one of our core project members in Belgium, he has actually managed to reverse engineer the speech codec, and now we can also decode the speech used on the satellite system. So yeah, that is already, as the slide slightly outdated. My apologies for that. Another project that we have is Osmocom DECT. DECT is Digital European Cordless Telephony. That's a cordless phone system. Probably many of you will have it at home or in the office. If you have a cordless phone attached to your wired telephone line, especially in Europe, then chances are very high it's a so-called DECT phone. It's a digital cordless telephone. And it's not just used in Europe, it's just the Europeans came up with this specification some time ago. And there was one project called dedected.org, which a couple of years earlier, I was also slightly involved in that. We started with open source protocol analyzers, so we again can basically look at protocol traces and explore and understand those systems. But now in Osmocom DECT, we have an implementation of the DECT protocol stack for the Linux kernel. So using hardware with the right chipset, you can basically run a DECT base station on software on Linux, which you can integrate with Asterisk or other VoIP PBX software, and use your regular cordless phones basically to interface with that. Yet another member of the family is the OP25 subproject of Osmocom. OP25 is the American police radio, a digital police radio system. When I mentioned Tetra, I said everyone in the world except North America is using Tetra. Well, North America is using OP25. And APCO 25 is actually the official name of this. I've never really looked much into it myself since I cannot receive any such signals, but apparently the people involved with this Osmocom project also had similar success like we had in the Osmocom Tetra project. Now, another part of our work is also to work on hardware. The picture is not very clear, unfortunately. My apologies for this. One project that we started is called Osmo SDR, which is actually a hardware project about a small, low-power, low-cost USB software-defined receiver. Has higher bandwidth than other similar inexpensive small USB receivers and much lower cost than other, like the USRP, where you have to pay like $800 or so. Open hardware developer units are available at this point. The project is unfortunately stuck a little bit because this was discovered, the RTL SDR. That's actually what you see here on the bottom is a very small USB digital television receiver. So basically you can go to any shop here and you can buy a small USB key that you plug into your PC, and on the other end you have an antenna socket and you put an antenna inside and you can receive DVB-T, digital television. The funny thing is that inside this receiver chip, you can actually, that's this on the right hand side here, the mouse pointer is located in this receiver chip. You can disable the built-in TV decoder and you can stream the raw radio data into your PC. Some clever people figured that out. Of course, it's not a documented feature. Now you can use these very cheap off-the-shelf, less than €20 TV receivers to receive anything but TV. TV reception is boring. Who is interested in TV anyway? If you can receive Tetra or satellite telephony or any other thing that you might imagine. The hardware is not open, but you have full free software support. There is a free software driver, which is implemented as so-called librtl SDR. And then you can use GNU Radio or Osmocom Tetra or any of the other projects on top of that. Another hardware project that we built is called the Osmocom SIM Trace, which is a protocol tracer for the SIM card. So basically you put this device between your phone and the SIM card. So you don't insert the SIM card inside the phone, but you insert the SIM card into SIM Trace and you insert the tracer into the phone. And by doing so, you can sniff, of course, and manipulate, if you want, the communication between SIM card and your phone. That is, again, interesting because SIM cards and specifically this interface, there are an incredible amount of things that could go wrong and that can go wrong on that interface and that could be abused, and it's very good to know about the technology and know about the risks that we are exposed to. Another open hardware project we have is an E1 transceiver. E1 lines, in case you don't know what that is, are sort of a ISDN type of line, which is also used a lot in the infrastructure of GSM and 3G networks. So we built a small interface so we can interface those lines more easily. There are also quite a lot of projects which are pure software projects for the core network of mobile communications networks. There's one family of those implementations in the Erlang programming language. Everything that I've spoke about so far in this talk is all pure C, no C++, pure C, very basic code. And now we have a certain family of network elements or protocol stack elements which are written in the Erlang language. And we have yet another new family written in Smalltalk, believe it or not. The reason is that some of the problems you're facing in the core network of mobile networks is you need a higher level language with certain properties to elegantly implement things there. So that's why there's a jump between programming language and a quite big one, of course, going from the macro assembler called C to a functional programming language. That's a pretty big step. So using those implementations, both the Smalltalk one as well as the Erlang ones, we can actually speak the protocols which are used on the roaming interfaces between the operators. Of course, it's a little bit difficult to get access to that. As a regular random guy, you don't really have access to those interfaces. But once you start to engage with operators who also have an interest in maybe finding out what's really happening in their network, you may have a chance to actually attach to such interfaces. And then you need a protocol stack and implementation using which you can explore those networks and look at security issues and whatnot else you might have in mind. Well, there are many more Osmocom projects. If you look at the Git Osmocom org website, the slide is slightly dated. By now it's probably more than 80 Git repositories that we have. Lots of different projects in various different topics related to mobile communications. Way too much to cover here in this short talk. Often you actually have to read the source code because documentation is very limited. That's the case when lots of technical people work on exciting code and there's so many other exciting things, so you never really write documentation. There's one project which is not part of the Osmocom family, but nonetheless I think it's worth mentioning here, is the OpenBSC project, which is a bridge between the GSM radio interface and the SIP voice over IP telephony system, completely unrelated to all the other code, but also an alternative free software implementation of mobile communications protocol. Another project is the AirPro project. I think by now it's mostly unnecessary anymore. There are better solutions by now, but still it was one of the first free software projects for mobile communication, and it's a software-defined radio implementation for listening, for tapping into the GSM radio interface. So basically what today you can do with a 20 euro Osmocom BB phone and Osmocom BB, you could do a couple of years earlier using an $800 USRP and AirProbe on your PC. You could do that, but today it's mostly unnecessary and mostly abandoned, but still, as I said, it was one of the first projects related to mobile communications infrastructure. Another open hardware project that's worth mentioning is the UMTRX, which is a software-defined radio hardware, not just for receiving, but also for transmitting, specifically for GSM. So if you want to run your own base station, that's one of the options. It's open hardware, so the full schematics and everything is released. Yet another project related to open source mobile communications, which is associated with Osmocom. One of the Osmocom developers implemented it. It's called XGoldMon. XGold refers to a specific family of chipsets made by Infineon, used in Samsung phones. So a Samsung Galaxy S2 and some Samsung Galaxy Note and some other of those use this chipset. And basically by using this software, you can get a full protocol trace of anything that your phone interacts with the GSM or 3G network. You can get that onto your PC, again feed that into Wireshark and observe everything that's happening on the communications interface. Yeah, there's a company that I'm affiliated with, which I'm going to skip. So where do we go from here? Well, a lot of the focus of the Osmocom work so far has been on old technologies. GSM was first deployed in 1992. And 17 years later, in 2009, we had the first open source implementation. I think that's a very bad track record, to have 17 years of basically not having open source implementations. Tetra and DECT and all these other systems also are similarly old. They're all 1990s technologies. So far, we yet have to see an open source LTE implementation or an open source HSPA implementation or any of the more modern things. There is research into microwave backhaul links. There is research into simulating and spoofing GPS, which, well, you can again buy very expensive equipment that can do that can basically broadcast a false GPS signal so your receivers think they're somewhere completely else. This is actually technology that has been used in the context of the Afghan war. Even by terrorists to basically obfuscate any kind of GPS trackers. But open source, at least, we don't have any implementations of GPS simulation today. Osmocom BB only works with one specific baseband chipset, which is already end of life for several years. So there's going to be a time when this chipset is no longer available and you will not be able to buy phones anymore. So it needs to be ported at some point to other phones. That is certainly on the to-do list. Right. Also, people have been doing research on reusing femtocells in creative ways. Femtocells are small base stations that you can put into your home if your operator supports that. It was big in the UK and in France. And some researchers of Technical University of Berlin have repeatedly shown attacks on those femtocells and how they can be abused in quite frightening ways, breaking the complete security not only of GSM but also of the later mobile communications systems. There are also quite a number of proprietary proprietary private mobile radio systems from Motorola and other vendors on which there is no documentation, which also would be quite interesting to do some more research and to reverse engineer those systems. So there's plenty of things. So basically, here's my call for contributions. If you think that all this internet and web and Ethernet and TCP/IP stuff is boring and people have been looking at that forever and it's old technology, look at many of the other exciting systems out there. I think IT on the PC is boring and is old. You should look at IT and security and communication in other areas, in embedded devices, not only in phones, but also in cars, in any kind of electronics that you can find today. There are communication systems. If you look at electronic identification cards, RFID systems, and so on, there's so many communication technologies that receive so little attention from the free software community and also from the research community in terms of looking at privacy aspects, looking at security aspects. So just my call, look at something else, look beyond the horizon and not just at the same thing that everyone else is looking at. I think that's, there are more exciting things that you can do. Okay, small thanks slide to various entities and individuals that have contributed significantly to Osmocom. If you have questions, feel free to ask. I know this was a very quick overview over many projects, but as I said, there are 79 more projects, and this was just the tip of the iceberg.
Applause first, or?
Yeah, thanks.
Amazing as usual.
What about DSL and DOCSIS and cables and stuff like that? Are there projects for implementing that?
No, I'm not aware of that. Out of curiosity, I read the DOCSIS specs and some of the SDSL specs some time ago. It's not too different, actually, in many aspects from software-defined radio, because in the end, it's communication technology. It's just your physical medium is not radio, but you're using copper. But you're using copper at frequencies where it behaves quite a bit like radio in the end. So it's actually fairly similar in many aspects, but no, I'm not aware of any projects in that area, which is quite a pity, because everyone can have a DSL line at home, but everyone just gets a consumer equipment and doesn't really know how it works and what it does and so on, and that's boring. People should look at that. People should attach interfaces that can give them the actual raw data, and they should explore how these systems work and how the modulation works, how the encoding works, and so on. But yeah, not aware.
So one comment, it's not just about security and being open source. It also creates a potential of other new actors having their own companies doing stuff like that. Providing alternatives to Broadcom, Infinium, Qualcomm in that core technologies. So it creates a possibility of creating a new company that will be more open and that will provide commercial products for end users or for providers.
Yeah, that's true. The reason why we had so little innovation in the mobile communications infrastructure world for so long time is because there were 4, 5, 6, 7 companies that had access to the technology, and if you're not one of those companies, you were not even able to innovate, because you wouldn't even get any of the parts of such a system where you could start to make your own ideas and to improve the system or to modify it in some way. That's where free software is so important. If we didn't have all the TCP/IP protocol stacks of Linux and the BSDs and so on, I think a lot less innovation would have happened on the internet if it wasn't for these free software implementations. And in the mobile world, we just didn't have them. That's, I think, a key issue why only large corporations, only very few could innovate in that area.
Any more questions?
What are the legal implications if you want to establish your own GSM network?
I would like to defer you to my talk tomorrow, which is on exactly the topic of running your own GSM network, and then I also talk about the legal aspects of that. Thank you. You're here tomorrow, right? Yeah, okay. Yeah, then. Thanks.
No, one more.
I'm sorry, I was hidden behind the pole. Which software-defined radio hardware would you recommend for a start? There is now HackRF and so many options. On the cheap, for example, for students or somebody like that.
Yeah, I would just go for the RTL SDR. You can't get cheaper than $20 or so. It's receive only, you cannot transmit. But still, I mean, in SDR, there's a lot of theory, a lot of software that you need to get at least some hold on and some understanding and some experience. So I think start with the RTL SDR, and once you because it's so cheap, you don't need to think about that expense. Once you hit the limits there, then you can think about the next thing to buy, and that changes every year or every 2. You find new hardware that has better properties and so on.
But if we already have the SDR, because we do, and want to start transmit at low power.
Yeah, then it depends a little bit on what you want to transmit. Which of the many projects is best. If you want to have an easy path, I think the USRP family, what's made by Etus, is still the best approach. They're expensive, but they're very easy to use. The software integration is close to perfect, and so on. All the other projects, they may not be so good on the RF performance side, or they may be good on the hardware, but then the software and drivers are more complicated. So all of them have trade-offs.
No more questions? Thank you very much, Harold.